There's some extra problems for section 2.4, section of chapter 2. Alright, at this point we're actually going to use the Venn diagrams to determine whether arguments are valid or not. If you know how to do the diagramming, there's just one extra piece to the puzzle. What you do is you diagram the premises, and if you look to the left here, I've written two premises for an argument already put into A, E, I, or O form. These are all A claims, and with the conclusion written below the line. There is a step in many problems and in being able to apply this where you need to get it into those forms, do the abbreviations properly, bring out negation, and so on and so forth. If you need more practice on that, it's part of the exercises in 2.4, but it's also in 2.1 where that's discussed in more detail. Just focusing on the diagrams and checking for validity here. So the method is this: you diagram the two premises, or however many premises you have, and then you look at the diagram and see if the conclusion is guaranteed to be true. Remember, we're talking about deductive arguments here, so the question is whether or not the conclusion is guaranteed to be true or necessarily true based on the premises. So I'm going to go to the first premise here, all A are B, and to diagram all A or B in the picture above, as we've learned, shade out areas 2 and 5, shade out the A's that are not B. Second premise, all A are C. To say that all A are C, we need to shade out areas 2 and 3. Area 2 is already shaded, so I'll just go ahead and shade out 3. You could double shade area 2, and that would be just fine as well. Now I've diagrammed what these two premises mean, and I can just take a look and see if I'm guaranteed the conclusion is true. Make sure you do not diagram the conclusion, otherwise any argument is going to come out valid, unless somehow you contradict yourself really quickly or confuse yourself. All B or C says that we don't have any B's that are not C. We don't have anything in areas 3 or 4. We do have area 3 shaded out, and we do not have area 4 shaded out, so there's no guarantee that all B are C, and this argument, therefore, is invalid. In this clip, by the way, I'm doing conclusions that are universal or general claims, all or no claims. And in both cases, whenever the conclusion is a universal claim, we're looking for a particular area being shaded out. This is going to be true regardless of the modern or Aristotelian interpretation. So we're looking for the area appropriate to the conclusion, whatever it is, to be entirely shaded out. Let's apply this in the second case to the right. This time we start out with all A are C. All A are C says that areas 2 and 3 should be shaded out. We don't have any A's that are not C. That's our first premise. Second premise, all B are A. Says to shade out areas 4 and 7. Let's put that on here as well. We cannot have anything. Remember, shading means what we can't have or don't have according to the information given. Don't have any B's that are not A. Areas 4 and 7. So we have that. Now we just got to look, see if we're guaranteed that our conclusion is true. The conclusion is all B are C. For that to be true, we would need to have the B's that are not C shaded out. We'd need areas 3 and 4 shaded out. Indeed, areas 3 and 4 are shaded out, so we get that this argument is valid.